Hey guys, coming back for part 2 of lesson 19.2. First thing I want to point out is the starburst over here that says homework number 1. So as you are working through 19.2 homework, this is the example that you want to be looking at. You want to be looking at this table. Okay, so we are solving these 3 systems of equations. And we can do it a number of ways. We could make a table, we could try guess and check, we could use number sense, or we could use Desmos. So it's up to you what you use. Desmos is probably the easiest, but sometimes we can use number sense to figure this out. So for number 4, we know that we have 2 numbers, x and y, and we know that when I add those 2 numbers together, I get 10. And when I subtract them, I get 2. So for me, I like number sense because I can go through a sets of numbers that equal 10 if I add them. So I know I have 1 and 9, I have 2 and 8, I have 3 and 7, and I have 4 and 6 and 5 and 5. And when I think about those numbers, I think about the 2 numbers that are going to give me a difference of 2 when I subtract. Okay, so I can use some number sense here, and I can say, okay, I know that 6 and 4 add to 10. I also know that 6 minus 4 is 2. So I can pretty quickly with number sense think of these 2 numbers. And then you're just being asked to check your solution. So we want to check and make sure that those 2 work. So if I have 6 plus 4 in for x and y, does that equal 10? Well, yeah, 10 equals 10, so we're good. But remember, if it's a solution to a system, it has to work in both equations. So not only do they have to add to 10, they also have to subtract and give you 2. So if I take 6 minus 4, do I get 2? Yes, I do. Okay, so I have checked my solution in both equations and it works, so I am good. Maybe number sense is not for you, and that's fine. You could always use a graph or a table, which we will probably do for one of these examples. Okay, example 5, y equals x plus 4, and 4x equals 12. So I look at this system of equations and I automatically go right to this second equation. And I look at that and I say, okay, this is really asking me 4 times what equals 12. And I can look at that and say, oh, well, that can only be one number. 4 times 3 is 12. So x has to be 3. And then I think, okay, well, if x is 3, then 3 goes in for x right there, and 3 plus 4 is 7. Okay, so again, for that one, I think it's relatively straightforward to use number sense. We just have one more thing to do, which is to check our solution. So we need to make sure that if I plug 7 in for y and 3 in for x, I get a true statement. And I do, because 3 plus 4 is 7. But remember, if it is a solution, it has to work in both equations. So I'm also going to check my second equation. And there's no y in my second equation, so I'm only substituting 3 in for x. And 12 is what I get when I multiply 4 times 3. And 12 equals 12. So my solution works. Okay, for this last one, 2 numbers that subtract to give you 5, and 2 that multiply to give you 84. That they have to be the same 2 numbers. So this one for me is a little bit more challenging because you could have infinite pairs of numbers that subtract to be 5. So you could have 6 minus 1, or you could have 100 minus 95. So there's a large list of numbers that would work for that first equation. And there's a good set of numbers that would work for multiplying to 84 as well. So for this one, I might go to my Desmos, I might go to my graph, and I think I will. So I'm gonna go back into Desmos and use graphing. Okay, so remember we type in our first equation, x minus y equals 5. And my second one is xy equals 84. Okay, I'm gonna have to do some moving around in my graph to find this one. Okay. All right. And the black graph on here is not a line, and that's okay, but we still are going to be looking for the intersection. So let's find the intersection here. Okay, we have 12 and 7, 12 comma 7. So let's go here, and I'm gonna write down 12, 7 as my x and y value. And remember, we have to check it to make sure that it works. So 12 minus 7 equals 5. 5 equals 5. That works. I'm going to check my second equation as well. 12 times 7 equals 84. And 12 times 7 is 84. So that works as well. I'm going to go back to Desmos really quickly. And maybe you saw it when I had it up before, maybe you didn't. So I'm going to scroll again. You can see that not only do I have an intersection at 12, 7, but there's another intersection on this graph as well. And that intersection is -7, -12. So we really should check that and make sure that that works as well. So I'm going to go back. And actually, let me make sure. -7, -12. Okay. So I am also going to write -7 and -12. And let's go through and check those. So let's see, if x is -7, then I would have -7 minus y, which is -12, and I am looking to see if that equals 5. Okay. If you remember your rules of adding and subtracting integers, when I subtract a negative, that turns to addition. So -7 plus 12, does that equal 5? Yes, it does. Okay, so -7, -12 works in our first equation. Let's check it with our second equation. So I have x is -7. And I have y is -12, and I want to know if that's 84. And when I take a negative times a negative, I do get a positive. So 84 equals 84. So in this system, and I'm actually going to split this in half here so you can see there we go, that we have two different solutions. In this system, we actually have two different solutions. And if we had just tried to look at this with number sense or tried to figure out two numbers that worked, we probably would have come up with the 12 and the 7, but we probably would not have come up with the -7 and the -12. So that's why I like to use the graph as well. So even if you are asked to solve something algebraically or you're asked to use number sense, it's always a good idea to go back and look at a graph to check your answer. And with Desmos, it's so simple, and you guys are so good at using Desmos. You did great with it in class, so keep using it for homework, and I will talk to you soon.